Hello. Thank you for coming to my talk. So my name is Lisa. I'm a web developer and sort of a maker, hacker. I make things for fun, and I'm a super fan of space exploration. And so today I'm going to talk about a few different ways to find space mission data on the web. Finding space mission data on the web can be tricky. There's a lot of it. We've sent nearly 200 robotic missions to space since starting around 1958. This infographic shows sort of the orbits that we've done around various planets in our solar system. The biggest circle there on the left is Mars. We've done a lot of exploration of Mars, less so in the outer solar system, there on the right. I need to take a breath. And one reason it's tricky to find data is space missions are enormous collaborations from the people that work on the spacecraft itself to the engineering to the science and the planning and analysis. Literally a cast of thousands work on every single mission. And if you think about a spacecraft, it's this vehicle that we've flung into space, and we attach to it several instruments. This is a diagram of the Cassini orbiter and all its instruments. And sometimes there can be up to a dozen instruments on every spacecraft. And these are highly specialized instruments. And there can be quite a learning curve to learning about the data that they collect. Each instrument has its own team of people that work primarily on that instrument. Sometimes instrument team members don't even talk to other members on other instruments. They're just that highly specialized. And it's usually the instrument teams that shepherd the data from space out to the web and out to the public. So it can be very distributed all over the web. But I'm going to give you a sort of a landscape view of where I see are sort of three different areas where makers and hackers and experimentalists can find data to make things. There's three general areas: search tools, APIs, and web scraping. I'm going to talk about search tools first. Search tools are like web forms. You go to a website, you fill out a form, and maybe you can view some data and do some downloads. There are thousands of these on the web. They vary widely in usability. They serve different communities. They vary widely, and I'm going to show you one that I'm intimately familiar with because I work on it for my day job. So I work for the NASA Planetary Data System. That's the program of NASA to take space mission data from planetary probes and put it on the web, release it to the public, and work with the science community on using it. It's divided into disciplinary nodes. So there's a small bodies node, and they focus on asteroids, comets, and interplanetary dust. And there's a geosciences node. They have all the Mars data and images. And there's an atmospheres node, and they deal with non-imaging atmospheric data. And the node that I work for is the Ring Moon Systems node. Our leadership are experts in planetary ring moon systems. So there's a whole community of people who study the outer planets and ring moon systems. So most people are aware that Saturn has these gorgeous, iconic rings. You can see them from Earth-based telescopes, but not everyone realizes that Jupiter, Uranus, and Neptune also have ring systems. They're very faint rings at these planets. So our node archives data from all missions that visit any planet with rings. So we have all the data from, for instance, the New Horizons mission. Even though that mission was primarily to go to Pluto, it had a very cool encounter at Jupiter too. So we archive all that data as well. So we made a search tool, and in fine NASA tradition, we gave it an acronym. OPUS stands for Outer Planets Unified Search, and the idea behind it is that we've combined several missions into one interface. And the problem we were trying to solve is that we noticed that in the planetary rings community that people were having to have a lot of web and spacecraft instrument domain knowledge just to find the data they were looking for to study, say, a moon of Saturn or the planet Jupiter. And we wanted to make an interface that let them focus more on what they were trying to study and bring together a bunch of data sets together to make it a little easier. So I'll just jump into demoing it for you. So the landing page is probably my least favorite page of the website. It's just really complex. So we're funded to serve primarily scientific research community. So there are some very specialized features, and it's rather complicated. And my bad joke is that it looks like a DMV form. But the UX is hard, right? Design is hard. But the idea is this. You start with access to all our results. So in the top blue bar, if you can see at the top, there's a big number. I think it's 1.2 million when I made this slide. That's a count of everything in our database. So for this tool, we archive the complete set of remote sensing data for several NASA missions, Voyager probes, Galileo, New Horizons, and Cassini, and there's some Hubble data sets in there as well. And the idea is that you want to search and narrow down your results to like a more reasonable number than 1.2 million based on what you're looking for so that you can browse and maybe do some downloading of data. The left column is this sort of monster list of parameters. So when a spacecraft takes a picture, it records with it a lot of metadata with that picture. The pointing angle of the camera, the angle between the sun and the target and the spacecraft, and a bunch of spacecraft state data. So we've made it possible to search absolutely all those fields. So that's why there's a lot of things in there. And the idea is that you can click on one of those and it brings up a widget in the middle. So there's two widgets showing right now, planet and target. Target means like moon or ring. And so the idea is that you can search by those parameters by clicking and filling out a widget. So I'll show you what I mean. I'll go ahead and click Jupiter here. And the first thing you might notice is that the number at the top got a lot smaller because you're basically saying, show me only results tagged Jupiter. And the other thing that happened is the target list for Jupiter opened. So you can see all the moons all the observations that we've identified as being of moons. So I'm just going to stop there and click the number, click the browse results, and what you get is sort of this infinitely scrolling gallery of space images. The default order here is ascending in time. So what you're seeing here is actually the earliest observations in our database, and this is Voyager 1. On its approach to Jupiter, it's just opened its shutter doors and started imaging Jupiter as it approaches. So the Voyager mission was two identical spacecraft, Voyager 1 and Voyager 2. They were launched a few months apart in the late 70s. Voyager 1 was the first to reach Jupiter. Both were on an original mission to explore Jupiter and Saturn, and they actually went on later to explore Neptune and Uranus as well. And Voyager 1 actually, having begun its mission as an interplanetary probe in our solar system, has actually left the solar system, becoming humanity's first interstellar probe. So I'm going to skip ahead. You can infinitely scroll, or you can enter page numbers. So I've skipped ahead here about 125 pages, forward in pages and forward in time. So this is still Voyager 1. It's gotten much closer to Jupiter now, and it's taking these very detailed close-ups of Jupiter's atmosphere and its sort of weird clouds and storms that happen all over Jupiter. So I want to say a bit about the color you might be picking up in these thumbnails. Space imaging cameras are most often black and white cameras. With a black and white camera, you can pick up a lot more information at each pixel than with a colored camera. And the way they detect color is they have a filter wheel in front of the camera. And so they'll drop in colored filters, and those filters allow them to measure intensities of light at different wavelengths or different colors. So for this gallery, we've given a false color tint to these thumbnails just as a visual cue to let you know what filter was used in that image. And I'll talk a bit in a minute about why that's useful. So I'm going to jump into a similar search for Saturn. This time I've checked Saturn instead of Jupiter. And the number at the top is now pretty large, and that's because most of the images in our database are taken near the Saturn system, and that's because of the Cassini mission. So Cassini launched 20 years after the Voyagers left Earth. They arrived and entered orbit around Saturn in July 2004, and it completed just under 300 orbits before just a few weeks ago the mission ended and they plowed the spacecraft into Saturn. So this spacecraft doesn't exist anymore, but we've got 500,000 pictures from it and data, and the science from this mission will go on for decades probably. So these are images from Cassini. So when I say orbits, generally when you think of an orbit, like an Earth satellite, and almost all the Mars satellites orbit at the same elevation above the planet for their lifetime. But to study something like Saturn and its rings, you really need some different orbits. So Cassini did these crazy orbits. The reason is if you're always in the same plane, like if you're in the same plane as the rings, you'll always just see this straight line. So you really have to get around to different angles in order to study Saturn's rings. And the other reason is there's 150 moons and moonlets in total around Saturn. Around 50 have been given official names, and around 60 have known orbits. So a lot of these orbits are planned to swing by these moons and really study those moons. Some of them have possible could harbor life. Very interesting moons out there around Saturn. One thing I love about Cassini also is, in terms of this interface, is it's a very stable platform for imaging cameras. So as you browse through Cassini images, you can see many sequences actually that just look like frames of a movie. So here's a sequence where Cassini was imaging the tiny moon Atlas. It's a tiny moon that orbits within the rings. And if you click the larger preview, and just kind of hold down the right arrow key if you have a good internet connection, you can sort of see this animation effect. So that's Atlas as it's sort of flying around its orbit at Saturn. So there are many sequences like this, and people have used Opus to make frame animation movies, adding music beds, getting really creative, without having to do any extra processing work to stabilize the scene in the frame. Here's an example. This is Greg Pugh. He is Lightning Rod on YouTube, and he's made these animations. He's found a lot of these, and he adds music and releases these on YouTube. You should definitely check out his videos. So I'm going to do one more example of a search that's really common, and that's an instrument search, and that's where we add an instrument. So I'm going to click instrument, and that's where you want to narrow it down to one spacecraft. So I'm going to select New Horizons here, and then Jupiter, and then I want to look at Jupiter's moon Io, and then we'll see the results here. So these are images of Io. The demo in this gallery, or this gallery is actually a shopping cart, so you can select images from here and add them to your collection, and then click the collection tab at the top to view what you've selected. And then you can download a zip file or a CSV. So some of you might be familiar with the New Horizons mission because it just visited Pluto last year and gave us our first images of Pluto. We never knew what Pluto looked like before. But it really also had a cool encounter at Jupiter too. And I'll show you what I mean here. So if you can see at the top of Io, there's like that bright bump. So it turns out that's actually a volcano that is erupting as New Horizons was taking pictures of it. This was not planned. You always hope that when you look at Io, you see something because we do know it's volcanically active. But this was just a stroke of luck that as New Horizons was leaving the Jupiter system and turned around and looked at Io backlit by the sun, that it picked up this plume. So from this set of frames, this is, we get the only existing frame animation movie of a volcano erupting on another world. So that's a 200, I know, right? So that plume is 200 miles high, and it's a little bit over the horizon, so we're just seeing the top, and its name is Tavashtar. I just think it's a cool name. So other uses for some of those parameters that we saw, you can narrow down resolutions and phase angles, so lighting angles. So these were made by Emily Lakdawala of the Planetary Society. She's a scientist and science journalist. And she creates these images that are collections of different planetary bodies in the same image to show scale comparisons and to teach and raise awareness about our solar system. So that's one thing. Speaking of, oh, okay, here, sorry. There's also a thriving community of people who create color versions of space probe images. So space probe cameras are black and white, and they have color filters you use to pick up different intensities of light at different wavelengths. It turns out if you can find 3 images taken with the red, green, and blue filter of the same scene, you can actually create color images. So there's a community of people who do this as hobbyists. Here's one by Ian Reagan. He has a whole collection of these. Here's one by Valerie Clavens. So they meet online, and I'll give you some resources later. But this is a really cool thing. And so this is sort of the color that you might see with your eyes if you were out there. You need just some Photoshop skills and some judgment calls, because we all see color differently. But a lot of the images that you see in the press, colorized versions of space images, are done by hobbyist community people. Speaking of image processing and movies, there is a large format IMAX movie coming out. So they're not using any like 3D rendering or CGI or anything like that to make this movie. Instead, they're processing over 7.5 million photographs taken from actual spacecraft and telescopes. So I'm going to play you a clip. It's going to get very motion-y here for a second. So during production, they used Opus to find suitable image sets to stitch together into very large-scale panoramas to create the effect of flying through space around Saturn. So this movie is actually due out, I think, later this year or early next year, so definitely Google. It's called In Saturn's Rings. So, like I said, we're part of the Planetary Data System. They have a central website. There's a lot of search tools you can explore. There's a search box up there in the right corner where put anything in there, Mars, Jupiter, whatever you are curious about, and you'll get a list of search tools. So that's something to think about. But if you're lucky, there's an API. I like APIs, so I'll talk about APIs. So Opus has an API. It's completely just open JSON API, requests over HTTP. Any search that can be performed in Opus can be performed as an API call. The URL structure is the same. So you can access anything in Opus through the API. So I'll show you a quick example. This is our data endpoint. I'm asking for data in JSON here. And I'm doing a search, planet equals Saturn, and I want to look at the target Hyperion, that's a moon of Saturn, and put that, issue that call, and you'll get a JSON response, and you can customize these values that you get back. Here's another example. This is our images API. So I'm asking here for medium images in HTML format, just so I can show you them. And I've just added a parameter of the instrument I want to see Cassini images. And you'll get these pictures of Hyperion, which is Saturn's weird spongy moon. So if you wanted to grab a lot of images, this would be a way to do it. If you change that .html to .json, you'll get a JSON response with direct links to all the image URLs. So that's a good way to grab images in mass. The way you get there is you go to our landing page. There's a link at the bottom, tiny link, and we have an API guide which has those examples and many more on how to use it. So people are using it. There's a couple of Twitter bots. This one is Planetary Bot. This one's by Geert Berenson. He's an astronomer with NASA's Kepler K2 mission, and he's a hacker, and he made this bot. He chose to go with the color images, the tinted images. We also have the full res black and white images in our API, but he said he just liked the way that the colorized versions looked. And I love this bot because I also love how he did the emojis in the tweet. It's kind of cool. Here's another bot I love. This is the Ephemeris by Alison Parrish. She spoke here yesterday. Great talk about computer-generated poetry. You should definitely check it out if you didn't make it yesterday. She's a computer programmer, poet, educator, and game dev, university instructor. Her teaching and practice address the unusual phenomenon that blossom when language and computers meet. Definitely worth checking out her work. She made this bot, the Ephemeris, and she says, quote, "The idea behind the bot was to address the similarity between space probes and generative poetry procedures from the opposite direction. What would poetry written by a space probe look like?" I love this bot so much. Generative poetry. So she went with the full-res black and white images, and she said, quote, "I love the raw images. Somehow they seem warmer and more personal to me, which fits into the fiction of the bot, that these poems are a personal documentation of the probe's own experience." So definitely check that out. She's got a great blog post that explains more about the generative poetry involved in making this bot. So there are other APIs out there. You should definitely check out NASA's data portal. It's at data.nasa.gov. They have a bunch of APIs here and a list of search tools and a lot of resources. I want to show you one little path through here because I found it a little bit hard to find, but it's really cool. If you click Data Catalog and then Data Lens, I have no idea what that means, but what you get is this list of data sets. And I'm going to click one here that is meteorite landings. And you get this page with like a map of the landings. These are meteorites hitting Earth. But there's also this link to an API. And if you click that, you'll get just directly linked to the JSON endpoint. And they also have really good documentation. So like they have this page that shows you how to work with JSON endpoints. And it even has like a Python snippet that you can just cut and paste. So this is worth checking out, data.nasa.gov. So those are documented APIs. The public is invited to use them. Anybody can find them, and they're well documented. Sometimes there's an undocumented API you can find. So I'll tell you a story about something I worked on where we used an undocumented API from NASA. So my friend and collaborator Ariel Waldman and we make space things, and we were between projects, and we wanted to make something new. And there's something that we thought didn't exist on the web, and we really wanted to see it. And that was a website that will tell you what are all the live active space missions that are out there right now. NASA has their own websites where they list their space probes, but there are several countries with space missions. The United States has NASA, of course, but China, Japan, India, and the European Space Agency, which is a collaboration of 22 member states, all have active space probes out there. So we wanted to make a site where you can see, like, what are all the space probes that are actually out there, still chirping back to Earth. There's a Wikipedia page. It does a pretty good job. But we're web designers, and we love beautiful things, and we wanted to make just like a really cool, beautiful site. I was super inspired by this site, howmanypeopleareinspacerightnow.com. There's 6. It's just one of these simple single-serving sites. If you scroll down, you can learn a little bit more about the astronauts. But I really love the idea of just being connected in real time to what's going on in space. And I wanted to see something like this for the probes. So we bought a domain. Thank you, country of Spain, for that .es domain name. And we made this website. My collaborator, I'm not a designer, I'm more the techie. She's a fantastic visual designer, and she came up with these spacecraft silhouettes. So this site lists all the current active space missions, and we keep it up to date. If a spacecraft crashes into its target, it's over, we take it down. If you click one of those, you get information about the probe, some links to learn more, a little bit of pictures about it. And again, this is all countries. But when we were shopping this idea around to our friends, like, what would you want to see in a website about space probes, we overwhelmingly heard they want data. Okay, maybe our friends are nerds, but people wanted like a portal to all the space probe data. But that's very difficult to do for the reasons that I mentioned before, but also different countries have different policies about releasing their data. But we did find sort of an undocumented data source. So the Deep Space Network is this worldwide network of radio telescopes. They're at 3 locations. It's run by NASA. They have contracts with different countries, and they just track space probes all day long. And they have this awesome website, deepspacenow.com, where you can see in real time what spacecraft the dishes are talking to. So the 3 rows are the 3 locations: Madrid in Spain, Goldstone in California, and Canberra in Australia. If you click one of those dishes, like I've clicked one in the Goldstone row, it'll tell you information about the spacecraft on the right-hand side. And because they're doing radio pings back and forth, they know the round-trip time travel speed, so they know the distance to that probe. So the probe basically reports its distance. So we thought that was a cool metric, like how far away are all the probes? That's kind of a real-time, like, physical thing that we can think about. So we wanted that piece of information for our site. So we opened up our developer tools and sort of watch the site. If you just run this site in your browser all day, it'll automatically update itself to be sort of real time what the dishes are doing. But if you watch what it's doing AJAX calls in the background to another service. And so your developer tools will show you the URL it's calling. And so we grabbed that URL to check it out. And this is what we got, which is not super inspiring. It's sort of a wall of XML. That was my response. But Python to the rescue. There's a Python library called XML To Dict. It's a utility that turns XML into a Python dictionary. So feeding it through that, now we can read it. So the top level, DSN, Deep Space Now, and then this is Canberra. We know what that is. That's one of the locations. And then a list of dishes. And then there's some stuff about the dish, the pointing angle, the wind speed, its elevation, and then there's this target field. And under that is a name. And we found this list of spacecraft codes that related to their names. That's the URL if anybody wants it. But basically what this is saying is it's talking to Cassini when I took this slide, which was before Cassini got destroyed. And then there's this field up leg range, and there's also down leg range. I don't really know what up leg and down leg, but the range field matches the number that they listed on that website. Range means the distance, shortest distance between 2 things. So that's actually a report of the spacecraft distance. So we put this scraper basically up on Heroku, turned on a scheduler, and in a week we had a full database of all the spacecraft. It turns out they communicate rather often. So that spacecraft distance is very near to the actual distance of the spacecraft right now. So that's how we're able to order our website by furthest at the top down to closest to Earth at the bottom. And we are able to show the current distance to the craft. And we have these clicky things at the top. You can sort of reorder by launch date, which is hard-coded, or by distance. So we're hitting our own API. We made our own sort of JSON, Heroku, Redis object that we just are continually updating. So we're hitting our own API. It's nice to not send your own website traffic to another to another website that's not your own. So we made our own API. The last area I want to talk about is web scraping. I really love web scraping projects, especially for beginners to web development, because you get to write some Python. It's sort of a standalone Python script, but you're also sort of forced to think about the way HTML is structured and how people create pages. So when I was first learning Python, I did a few scraping projects. I used Beautiful Soup. It's very forgiving of broken old HTML, and it's just a very intuitive scraping tool for Python, and so I usually recommend that to people. So here's an example of something I've worked on that was a scraping project. So my same friend, Ariel Waldman, and I excuse me, we were at a hackathon on the subject of Mars, and so we found this website. This is the HiRISE website. HiRISE is an instrument on the Mars Reconnaissance Orbiter. It takes absolutely gorgeous photos, and they put it all on this website. This is very well-structured HTML, so thanks, high-rise team at Arizona State. But so we wanted to make we thought these images were so beautiful. Like if you click on one of these thumbnails, you get the full res image, some caption, content information about it, and the image credit. And but their website, it's a little bit like the thumbnails are small, there's no infinite scroll, you have to click, click, click. So we wanted to do something more graphic and just really bring out these images. So we used WordPress. We had one day, we scraped the site, we got this JSON file when we scraped it using Beautiful Soup. And then we sort of fed that into a WordPress site, and we made marsfromspace.com. And again, this is on like a cron job or a scheduler, so it keeps up to date with the high-rise main website. And we just wanted to have this really in-your-face experience of these gorgeous pictures. And this is sort of one of these long, infinitely scrolling pages. If you click on one of those, you get a very big image and the content and the image credit and a link back to the high-rise website. And the way we did this is we like WordPress because there's a really there's a huge community of design themes that you can buy off the shelf. So you don't have to design a website, you can buy a theme and just install it. And if you're not familiar with WordPress, it's actually a blogging platform. You sort of log into the admin, type up a blog post, upload an image, and then you have a blog. But there's actually a lot of, there's a plugin directory that extends the functionality of WordPress. So we used this plugin, we installed WordPress on a WordPress site on like DreamHost, I think. And then we installed this plugin. It's called, where is it? Xml-Rpc Modernization. That's quite a name. What it lets you do is basically create WordPress posts on your own machine with Python and then send them over the internet to your WordPress site and create a post. So we looped through our scrape of the high-rise site and just created a post on our remote WordPress site. And so we let it run for about an hour and a half, and then we had this website with all these images and posts. So that's kind of a good strategy if you want to make a pretty website at a hackathon in a short amount of time. So that's about it. I have some resources I want to tell you about. I mentioned data.nasa.gov. There's a lot there. The Planetary Society has space image processing tutorials. So if you want to get into making colorized versions and exploring space images and looking at different planets than I showed you, you should definitely check out planetary.org. There's also a really good blog post there by Emily Lakdawala, where to find rapidly released space image data. So I've showed you some archival places, but there's also places where the images are released very soon after they hit Earth. So those are worth checking out. I want to mention NASA Datanaut. It's a program by NASA to improve the usability of the data landscape at NASA and to engage with the growing data tech maker community. They work with a group of people each year. I think they're doing it twice a year now, actually. And they're very generous with time and resources to help people learn how to find and use NASA data. It began as part of NASA's Women in Data focus, intending to create a safe space for newcomers to the data science frontier, especially girls and women. And it's open to anyone now, but it still very much has that vibe. So I would definitely encourage you to check it out, and especially if you are an underrepresented woman or person of color who does anything with data, definitely check out NASA Datanauts. It's a great program and a great way to connect with other people that are doing this kind of work. Thank you so much. I'm happy to take questions afterwards.